in this video, I just want to explain the mechanics of a direct proof. So how to do a direct proof. I won't actually prove anything, I'm just going to explain how one goes about doing this. All right, so let's say we have a statement of this form, P implies Q. If P, then Q. Let me just write that, or you could see this, maybe I shouldn't use the word or because I don't want you to confuse that with an or statement or something. So another way to say this, you might see it like if P, then Q. Okay, this is a if-then statement. Both of these are, when you write it like this, when you write it like that, you mean the same thing as what we have here. Okay? All right, so let's say we have one of these statements of this form, if P then Q. And let's recall our definition for this kind of statement. So we have P, Q, P implies Q. Now P and Q are themselves statements, right? Remember that? P and Q are themselves statements. True, true, false, false, true, false, true, false. And our definition is that the only time it's false is then, is when we have true assumption and false conclusion. That's the only time that it's false. Okay, so now think about this. Okay, so the way that you prove one of these is you assume P and you show or prove Q. Now this is now I'm going to explain to you why this makes sense that we can assume P and show Q. And what I'm basically teaching you right now is the proof logic, or the logic behind why the proof works. And if you look at the description for this class in the BSU course catalog, it says proof logic, and that's one of the things that the computer science department has said that they want me to teach you, is proof logic. So here goes. Okay. So we live in a world of truth or falsity in mathematics, right? There's no gray area. Things are either true or they're false. There's no sometimes, which is really nice, I must say. So P is either true or false. Okay, so now let's think, okay, what happens when P is false? When P is false, that puts us in these two rows here. And in these two rows, it's always true, right? True, right? So if P is false, then it's true, okay? Now if P is true, then that puts us in these two columns. Okay, and so that's the idea, right? Is that P is either true or false. There's no gray area. If P is false, then P implies Q is true. And if P is true, well, then okay, then that's where we have something to prove. So this is why we may as well assume that P is true, because if we assume P is false, then the statement is, then P implies Q is automatically true. So we may as well start with the assumption that P is true. And then our goal is to eliminate this row, thereby proving that P implies Q is true. And that's essentially it.